Hello, my friends. So, last night I got a little bored and I decided to make some sparks and see just what the LDMOS will put up with for myself. Up until now, the only time I've really tried to run an LDMOS with an open or a short circuit is on accident. And I've learned a few lessons. I've learned that LDMOS is not entirely impervious to short circuits and open circuits on the output. There are certain circumstances where, an open or a short on the coax will blow up the FET. That said, they can put up with a lot. And the lower the voltage you run them at, the better off you're likely to be if something crazy were to happen. So I just started playing with it last night and firing it up and Arcin and Sparkin and all that stuff. And I figured I'd take a video for you guys to see what's going on. So, got the other camera over here rolling. And I'm going to use the cell phone camera for audio, and I'm also going to use it to show you guys what's all connected so you can see exactly what I'm doing. Right now I'm running a water-cooled pallet, and the hoses are going over here, and they're zigzagging over there to a radiator, a fan, and a water pump. I got this power supply over here. It's going to be running at 50 volts for this test. Bird watt meter coming straight out of the pallet. So that's a 1,000 watt slug, and it is in reflect right now. So on the other side of the slug, I've just got an open piece of cheap RG58 coax. It's about 12 feet long, or whatever I cut it to last time I was messing with it. We're just going to run it straight into an open circuit. So right now the pallet is being driven by. Let's follow the chain back. So we've got our LP100 coupler, and that is measuring the input power to the pallet. So that's up here on this meter. And before that we have an attenuator, so the RF source is getting attenuated down a little bit. And our RF source, if we follow this wire back up, is coming from my little benchtop LDMOS driver amplifier. And that amplifier takes the signal from my function generator, so that cable right there, and amplifies it up to a reasonable level. So if you guys didn't know, this function generator puts out about 0.5, 0.6 watts. And this little box right here just helps me amplify that up a little bit. So this is capable of putting out AM power, and that's what we're going to be doing today. We're going to be doing AM modulated power. We're going to be peaking at 10 watts going into the pallet. So I'll actually be driving 20 watts into this 3 dB attenuator, and that'll get cut in half by the attenuator. And we'll be driving 10 peak watts into this pallet, and then straight out into nothingness. Alright, let's fire some stuff up over here. Okay, let me start a little bit lower. Alright, so right now we're putting out 1.5 peak watts, and that's getting us a few bird on the meter. And it's all coming back, 200 watts maybe. All 200 watts is coming right back. And that's coming out of this coax right here. Actually, it's not really going anywhere. Our power supply is drawing 1.8 amps. And that's because this is about a half-wave jumper and it's an open circuit. So the amplifier is seeing about an open circuit right now. Let's crank that up a little bit higher. Okay. Okay, about 10 watts there, about 10 peak watts. And we're modulating. Safety first. We're modulating an AM sine wave. And this is the reflected power. Let's see what the peak reflected power is. It's about 500 watts. Yeah, these amps don't really make any power when you don't have something connected to them. And I think that has something to do with why they're so durable. You can kind of see it Arcin and Sparkin there. Alright, well, I'm going to switch over to the other camera. And hopefully we can have some fun here. Oh, come on. Getting good sparks earlier. There we go. Putting a little fire in the wire. So hopefully you guys can see the amp draw that the pallet is drawing. When the circuit is open, it's drawing very few amps, but when I short circuit, the amp draw gets pretty high. And I think that a lot of that power is going into the coax itself, because this coax is getting very, very hot. So I've always been curious about how much power is actually being dissipated in the pallet versus how much is being dissipated in the coax. And just judging by how hot this is, I think there's a significant amount of power being dissipated here. So that's our forward power. Let's do that again and see what the forward looks like. Oh. Kind of Arcin and Sparkin. It's like an RF flamethrower. That's pretty fun. So the water cooling is obviously keeping this pallet really cold the whole time I do this. You know, I don't know how an air-cooled pallet would fare if I tried to do this with it. Probably get pretty warm pretty quick. Come on. This is cheap entertainment. Give me some sparks. Cheap entertainment. Yeah, like I said, it's an open circuit right now, so it's not drawing much of anything. It's crazy that it's still burning though. Woo! It's crackling and popping. And it's crazy how little power it's drawing right now. It's just kind of resonating into nothingness, and you know, I don't know what that is. I'm guessing that's like a really high voltage or something going on there. You know, I don't really understand the physics of what's going on when this device is open or short-circuited. You know, I never really cared that much. I mean, I didn't build an amplifier to arc weld with it. I built it to talk on the radio, so honestly, SWR handling and short circuit, open circuit handle, how well the pallet handles that, I've never been concerned with it. I really don't care. It's like buying a Toshiba amplifier. You don't buy it to come over here and arc weld with it. You buy it to talk on the radio. But I've never done this, and I've always wanted to get around to it. And I'm kind of bored. Don't have anything else going on my workbench right now. So, there she be. Let's do a little more. Uh-oh. I think my coax might be melting. Oh. Man, this coax is hot. There might be a short circuit in there somewhere. Yeah, the pallet's still making power. Get a little Arcin and Sparkin going on. Let's try cutting it right here. There we go. Alright. I better cut that out before I catch the coax on fire, because it's pretty hot. Yeah, man, there's a lot of heat going into that wire. It's crazy how the coax is just soaking up all that heat. Man, it's too hot to touch. I think the coax actually melted and shorted inside because RF wasn't even making it out the end of it. But anyway, I hope you guys enjoyed that, because I did. It was fun. Flamethrower, RF flamethrower. First time I've ever really sat down and just kind of done that. But anyway, just keep in mind for you guys, it's really kind of pointless to do this. There's other than stupid entertainment, there's no point to it. It's just fun. And you know, you start cranking up the voltage and you really, really risk blowing up the FET. I've definitely blown up a couple of FETs at 65 volts. Like once you get up into that ballpark range, they're kind of on the verge of destruction, self-destruction. And 50 volts, they're super sturdy. They don't generate a lot of heat. This pellet puts out about 1400 peak watts if you run it at 50 volts. And that's a super safe number to be at. You know, if you're clumsy and you screw up your coax a lot, then you should probably be running this thing at 50. But if you're like me and you just want maximum power, run it at 60, you know, have some fun with it. But anywho, I'm Mud Duck Sharky. I think I think I'm satisfied on the boredom department for now. But yeah, I'll be back with another video soon. Thank you for watching, and I'll see you next time.